In this last section of this module, we're just going to spin up a few more containers from third-party images just to really reinforce how easy it is to spin up third-party software in Docker. So first of all, we're going to look at, if we go to Docker Hub and look at SQL Server. Now, strangely with SQL Server, it doesn't seem to, I don't understand these search results. I don't know why Redis was at the top. We have to scroll down a bit. Normally it's a bit better than that, but with SQL Server, it seems a bit odd. You'll also notice that this has 0 downloads. If we click into it, we can see this actually shows 50 million downloads. So there's obviously a bit of a bug with Docker Hub there because it's different views showing different information. I suspect this is something to do with the fact that Microsoft images are stored on their own servers. And I've intentionally chosen SQL Server to explain this point, but it's not just a Microsoft thing. Basically, if we copy this into the terminal so you can see it properly, and just get rid of the Docker pull so we can look at the actual image name. Now you can see that this, unlike other stuff we've looked at, is prefixed with a domain name. So with Nginx, that was just Docker pull Nginx, but this has got a domain name in front. Now I mentioned when I spoke about image registries that Docker Hub was the default registry. So if you don't prefix it with a domain name, it will assume the default Docker Hub. If you want to use another image registry like your own, or Microsoft hosts theirs on mcr.microsoft.com, then you've got to prefix it with that domain name. So for example, I host a lot of mine in private container registries in Azure. They have a service called Azure Container Registry. And if I created an Azure Container Registry called Dan Clark, this is what the domain would look like. And I would follow that up with my image name. So if we go back to Docker Hub and look at the SQL Server page, scroll down a bit, let's find an example with a port number. And the first one does have that, so let's copy that. So we can see here that we're using the -e command line argument to pass in an environment variable, and SQL Server expects you to pass in one saying that you accept the EULA, and that's what we're doing here. We're also passing in one to set the password, the SA password. What I'm going to do is I'm going to remove the -d because we want to see the output logs. We don't want it detached. I'm going to change the password to something smaller. Let's go for like Dome Train. Let's #123 because this will require uppercase and lowercase, a symbol, numbers. So let's do that. And now we have SQL Server running. So then if I go over to Azure Data Studio, now this could be any SQL client or your software, obviously. And then just connect. So it's going to be localhost in the same way as we saw other stuff in the browser. Choose, oh no, sorry, we want SQL login. So it's SA, and then our password, DomeTrain #123, and then connect, and then we're connected. Now, obviously this is not a course on SQL Server, so that's the extent I will show. But I basically no longer have SQL Server installed on my machine. I used to remember the days when I used to have SQL Server installed on my machine with a whole bunch of databases for different clients. I had IIS installed on my machine. Now I don't have any of these things. I just have Docker. And for each client, I spin up dedicated SQL Server, RabbitMQ, or whatever it is that that application requires on demand for that project. And then at the end of the day, when I finish working on that, I can tear it down again. So if I stop this now, and let's have a look at another one. Let's look at Grafana. Now, Grafana is an amazing dashboarding tool to show observability type of dashboards. So if we click on this, copy this command, it's got a port number, so that's fine. And then run this, get rid of -d. Right, we now have an error actually. Now this is because before at some point today, probably I would have spun up a container called Grafana. And it's saying the name is already in use. So let's just delete this. It's kindly given us the container ID, so I'm going to copy this. If I remove that and paste it in, and then try our command again, now we can run Grafana. So if I go to localhost, it was 3000 we saw when we did the port mapping. Then if we go back to Docker Hub, we can see the documentation says the default credentials are admin. So let's copy admin and paste that into those. Now it's saying it needs a new password. So I'm just going to put admin again. It's in the clipboard, so why not? And this is Grafana. So again, it's not a course on Grafana, so I'm going to very quickly show this, but I kind of want to highlight how easy it is to spin up stuff that we can use for local development. So let's let's look at the data sources. So Grafana is a dashboarding tool that supports lots of different data sources. So here's a few. It even supports SQL Server. We can see SQL Server here. It basically connects to lots of different external data sources. We're not going to connect to those at the moment though. Let's just create a dummy dashboard, add a visualization, and then you can see here we can use some mocked data here. So if I click on that, then we've got a nice graph, so we can save that dashboard. And we have a nice dashboard. So super simple. We can just use Docker to spin up these things locally. And I do actually use, as well as SQL Server, I use Grafana for my local development. We'll speak about Docker Compose later, which you can use that to very quickly spin up multiple containers. But I use Docker Compose to spin up Grafana, the data sources, SQL Server, RabbitMQ, a whole bunch of stuff in one command, which is just so powerful, which we'll see later. So lastly, let's have a look at one more image. I'm going to look at WordPress. I've actually got a good friend that really takes the mick out of me because he knows how much I dislike WordPress. So this one is for him. I'm going to spin up WordPress. First result, WordPress. If we scroll down a bit, find one with a port. So not that one, that's another port. There we are, there's an example with a port. Let's copy this. I'll get rid of the -d so we can see the logs. I'm going to get rid of the name as well, actually, just to avoid the issue we saw before in case I've already run this before with the same name. Now we've got WordPress running. If we load up the browser, I think it was 88 to the port number. And now we've got WordPress running. So this does require a database, typically MySQL. So you'd populate this here. We can spin up MySQL in Docker. I'm not going to do that now. But again, this just really shows how super simple this is to do. So that's the end of this module. Hopefully by now you have a really good idea of how to spin up containers from third-party images. In the next section, we're going to dig further into images and how they work with layers and caching. And after that, we're going to create our own application and see how we can build our own images. So in this section, we're going to talk about images, more specifically tags. So I'm not sure if we've run this command yet so far, but the Docker CLI is this command docker images. If we run this, then we basically get a list of all images I've got locally. So if I've done an explicit Docker pull image name, or if implicitly I've pulled the image by doing a Docker run, I've got them locally. Now, if you look on the left, we can see that we've got the image names repository column. Then we've got the tag column and we've got the image ID column. The image ID is a hash of that image. The tag is a pointer to that image ID. So it's important to note that the tag is not part of the image. It's just stored separately. Tags are just a whole bunch of pointers to images. So let's find a command we've run before. And in case you don't know this, in Bash you can do, or Bash or PowerShell, you can do Control-R to do a reverse history search. So I'm just doing a reverse history search for RabbitMQ, which brings up this command, which, if you remember from the section when we're talking about -p for publishing ports, we ran RabbitMQ. Because we were talking about publishing ports, you might not have noticed that the image name had a colon in it. So the format of this is, to the left of the colon is the image name, to the right is the tag. If you don't specify the colon and the tag, then it defaults to latest as the tag name. And as you can see, there's a lot of the tags that have latest, because when I was running those, I wasn't specifying the tag explicitly. But in this case, I did, because RabbitMQ has the management tag, which has that UI that I showed you, so I explicitly wanted to show that. If we go over to Docker Hub and the RabbitMQ page, then scroll down a little bit, we can see that there's a whole bunch of tags listed here. This is very similar on all the Docker Hub image pages. And you can see straight away that there's lots of version numbers, and that's the core reason for having tags. For the same image, like RabbitMQ in this example, obviously they want to be able to release later versions. But there's other uses as well. So for example, in this case, they're using management tag to indicate the version that has the web UI versus the version that doesn't have the web UI, so the lighter weight version. You could also use it for things like architecture. So ARM versus AMD architectures. You could use it if you had like a beta version to tag an image that this is the beta version. So there's lots of use cases for these images. If we look at this diagram now, then imagine this is just the same image, RabbitMQ or whatever it is, but the author has done different versions. Tags along the bottom, v1 is pointing at one version, one image ID, v2 is pointing at another, and we've got this latest tag. So it's important to note that latest is not special, it's just the default one. So if you don't specify it, it will assume the latest tag. But what happens if the author of this image creates a new version, so version 3? So going back to what I was saying before about tags just being pointers and not being part of the image. So tags are mutable. So a tag could be pointed at a different image ID, which in the case of latest, we can see that we can just do something like this. That is an explicit action. So when an author creates a new version, they would explicitly tag it with v3 and latest, but by doing so, they're reassigning it to the latest version. Whilst image tags are mutable, as we can see with this latest, generally, all the other tags, it's recommended that you treat them as they're immutable. So for example, v2 points to that image ID. Generally, it shouldn't change because that might cause confusion. So generally treat them as immutable, but note that latest is one that is treated as mutable. And it's always recommended, especially in production, rather than relying on this latest tag, when you're specifying your image, be explicit, say image : and then the version you want. So if we go back to the command line now and look at one other command, docker tag. So this allows you to basically explicitly tag your images. So the format is docker tag source and then your target image and tag name. So for example, if I copy one of these image IDs, this can be the source. So we're creating a new tag for that image ID and call it my image : my tag, something like that. And then if we do docker images again, then we can see that we've got my image, my tag, but the image ID is the same as the Nginx one, which is the one we copied it from. We can equally just say docker tag and give it Nginx, the same image name. So if I change this now to Nginx and then, I don't know, some version number, and then do docker images again, we can see that is listed there. So we can see that we've got 3 images with the same image ID. So multiple pointers can point to the same image ID, and a tag is just a pointer. There's this command called docker RMI, so remove image. This can be used to remove images, but also just remove tags. So if I do like RMI and Nginx, and then my v999, then it's untagged it. If I'd done docker RMI, then an image name, then it would have removed that entire image. I could have also specified an image ID. So what docker RMI does depends on what you've passed it. And it can delete images and it can untag things.